Hi friends, welcome to lesson 23 and happy Deepavali everyone. And today we're gonna learn theorem number 8. Okay, so before that, let's check our previous homework first. Let's go. Let's recall back what we have learned in theorem 7. So theorem 7 tells us that angles in the same segment are equal. So these two angles are the same, these two angles are the same. Okay, this looks like a butterfly, right? Okay, so try number 9. Let's check your work. Number 9, 54 and 73. Please tick your answer, please mark it. And try 10 is x is 53 and 37. And number 3, okay, I have written all the answers here already and I have marked your work. Okay, well done everyone. Okay, 3A here, 3B, 3C and 3D. Okay, I think there's no problem in question number 3. Okay, question number 7. Okay, DBC is 108 and DBE is 34. Right, please check your PDF. Please open the PDF and check the one that I already marked for you. Okay, number 8A, 21, 85 and 29. Okay, please double check and mark by yourself. Alright, let's go to theorem number 8 now. Theorem number 8 tells us that the sum of the opposite angles, okay, of a cyclic quadrilateral is 180 degrees. Okay, I'll explain to you one by one. Sum means total, okay. Opposite angles, so the angles that are opposite in this circle here is A and B and X and Y. These are called opposite angles of a cyclic quadrilateral. Quadrilateral means 4 sides, right? Okay, so cyclic quadrilateral is a special name of a quadrilateral that is inscribed on this circle. Okay, what does it mean by inscribed on this circle? It means that the 4 vertices of this quadrilateral must be lying on the circumference of the circle. Okay, so these 4 vertices, if you notice, it's on the circumference. 1, 2, 3, 4. 4 vertices on the circle. If inside the circle is just a normal quadrilateral, okay, it's not called cyclic. Cyclic must, the vertices must be on the circumference. Okay, if let's say we have a quadrilateral inside the circle like that, let's say this is a quadrilateral, let's say this is not called cyclic quadrilateral, it's just called normal quadrilateral, quadrilateral basically. Okay, so cyclic quadrilateral is a term that you will learn today. Okay, it's 180 degrees. Okay, so meaning to say that the total opposite angles, this and this, the sum, these two plus together is 180 degrees. Okay, and these two plus together is 180 degrees. Now you look at this circle over here. Okay, this quadrilateral is called cyclic quadrilateral. Okay, a special name for this quadrilateral is called cyclic quadrilateral. Why? Because these 4 vertices are on the circle. Okay, so this cyclic quadrilateral, the properties of a cyclic quadrilateral is that the opposite angles, okay, you look at this, I focus only one pair of these opposite angles. These 2 plus together is 180. You see 110 plus 70 is equals to 180. Okay, what if I move around? Let's say, okay, this is also a cyclic quadrilateral and these 2 opposite angles, will always add up to 180 degrees. Okay, always add up to 180 degrees. And same goes to the other opposite angle. This one and this one plus together is definitely 180 degrees. As long as these 4 vertices are on the circle, okay, 4 vertices only, not 5, 4 quadrilateral, and the opposite will be 180 degrees. Okay, let me. Okay, it's also 180 degrees. You do like that, it's also 180 degrees when you plus together. This one plus together 180 degrees. Alright, see that? Okay, so try 11. Here, you also copy only the circle. You don't need to copy the whole question unless if you want to print it out and stick it into your notebook. Alright, so try 11. Okay, first question here. This is page 102, by the way. This question is already here on the diagram, so we just need to look for, okay, part A, R, Q, and S. Okay, I'm gonna zoom in. RQS is this. Okay, so we're gonna find this. Okay, so this circle here is a combination of a few theorems. Okay, one of the theorem here that I can say is angle in a semicircle is 90 degrees. Can you identify where is the 90 degree? I give you a few seconds to figure out. Ready? 90 degrees here and another 90 degree is over here. Okay, and you can say that this is angle in the same segment are equal also can. Or if you can see this is a diameter, so this is 90 degree, this is also 90 degree. Okay, so we are finding this RQS over here. Okay, and we have this 28. Okay, we have this 28. All right, and then what else do we have? What else can we find from here? As you can see here, all right, this is a straight line. Okay, so these three angles, 60, 90, and this one is an 180. So we can find this angle here by using 180 minus 90 minus 60. Okay, I will get 30 degree. Okay, so this is 30 degree. And this is another theorem that you can see. It's called angle in the same segment are equal, right? So angle in the same segment are equal is here. So we can see a butterfly here. You can see like that, and like this, the same segment is over here. So this one and this one is the same. So here 30, here is also 30. Okay, then we can find this angle already lah. This one. How to find? If you can see, this is a 180 degree, is a triangle. So we can find angle SQR or angle RQS, okay, which is equals to 180 minus 90 minus 30 minus 28. Okay, minus this, and this. Okay, so you press calculator and find the answer. Okay, so the answer here is 32. SRP. Okay, so they are asking for SRP. SRP is here. Okay, and here, this SRP, you can see this angle in the same segment are equal, right? The butterfly, if you can see this, a butterfly here like that, this one and this one same. This segment is here, so this angle is 28, this angle is also 28. So we can find straight away our SRP. Okay, that's all. Easy, right? This one is 28. Okay, see, the question is SPQ. Okay, let's look at where is SPQ. SPQ is this one, this whole thing. Okay, this whole thing here, SPQ. So to find that SPQ, there's a triangle here, you can see. Okay, there's a triangle there. So 180 minus 90 minus 28. That's it. And you will get 62 degree. Right? So that's all for try 11. So this is try 12. So they are asking for angle T. Okay, I'm going to zoom in. Okay, angle T. So now we have two circles. Okay, this is a very interesting one. These two circles, and this is quadrilateral definitely because of four sides. But is this a cyclic quadrilateral? This is my question. Is this a cyclic quadrilateral? The answer is no. This is not a cyclic quadrilateral because cyclic quadrilateral is only in one circle. Okay, we have two circles here. Okay, we have two circles here. So if we divide this line like this, okay, then we have cyclic quadrilaterals. We have two cyclic quadrilaterals. One is over here and another one is over here. For this cyclic quadrilateral here, the vertices is on A, F, E, B. Okay, so this is a cyclic quadrilateral. Another cyclic quadrilateral here is B, C, D, E. Okay, it's on this circle. So we have two cyclic quadrilaterals. Okay, this whole thing is not cyclic quadrilateral. It's just a normal quadrilateral. Okay, so we want to find T. We know that these two plus together is 180. Okay, according to the properties of a circle, these two plus together is 180 degree. This 70 degrees, so the opposite angle here will be, this one will be 180 minus 70, which is equals to 110. Okay, so if this is 110, okay, I'm gonna write it here. This is 110. Then the angle at the side here, since this is a straight line, so this angle over here is 180 minus 110, which is equals to 70 degree. Okay, so I'm gonna write here 70 degree. Okay, what can you see from here? Okay, what can you relate from this circle here? Okay, because I'm gonna teach you another thing here. Okay, this is 70 degree, right? This is 110. And the side here is also 70, meaning to say that this angle here is the same as the angle outside here. The external angle 70 is equals to this 70 degree over here. Alright? Okay, so you remember that this angle 70 is 70. So T is definitely the same as this 110 lah. This T will be equals to 110. Okay, if you cannot think of that way, you can put it this way. So your angle T will be equals to 180 minus 70 degree because this is opposite angles. Okay, they sum up to 180 degree. So 180 minus 70 is 110 degree. That's all. Easy, right? Okay, the thing that you need to know is the 70 here is also 70. If T is here, 110 is here. Okay, I go back to this theorem again. Okay, what can you see from here is actually if we have an extended, okay, this is extended line. If let's say this is an extended line. Your x is here. So here will be also x. New thing. And if you extend the line over here, then this angle here will be y. Okay, it will be the same as the y here, this angle here. And if this is A, where do you think the A is? Okay, I'm going to draw the line here. This will be your A. And if this is B, then the other angle here will be B. This is the extra thing that I want to teach you. Okay, so that's all for try 12. Okay, go to exercise straight away. Exercise 3.2. This is question number 4. Okay, we're gonna do all 4 A, B, C, D, E, F. If can, you scan it out and print it up and stick it into your notebook, right? So it's easier, you don't need to draw. But some of you don't have printer, so you copy it down, right? Okay, so number 4, I think some of the questions here you can do. 4A you can do it yourself. 4B also do it yourself. Maybe I'll give you a little hint here first for 4A. Okay, I'm going to zoom in. You find x first. This is theorem, the twice. Remember twice? Okay, you find it out. Which theorem is that? The twice. Okay, angle in the at the center is twice the angle at the circumference, right? And then you use another theorem, which is the one that we just learned today. This opposite angle is 180 degree. Okay, you find x first and then you use 180 to minus x to find y. Okay, B is easy. To find x, okay, this is opposite angle. Okay, and then this is a triangle, so 180 minus x minus 35, you'll get y. Right? Okay, part C, I'll give you a hint also, you do it yourself. This is an isosceles triangle. So if this is isosceles triangle, it means that this is also 56. Then this is a triangle, right? You can find x lah. 180 minus 56, 56 to find x. And then this is opposite angle, 180 minus x to find y. Okay, you can do it yourself. Okay, D also you can do it by yourself. Okay, this is a 90 degree. Okay, it's an angle in a semicircle. And then this is opposite angle. This one and this one is opposite angle because this is cyclic quadrilateral. So 180 minus 55 minus 90 to get x. Alright. E, I give you a hint also. Okay, I give you a hint for part E. Okay, there's two cyclic quadrilateral here. One of the cyclic quadrilateral is this. So x and 103 are the opposite angles. Okay, this is the first hint I give you, so you can find x, right? And then, if you can see, this is another cyclic quadrilateral. The y and this, but of course you need to find this angle here first. Okay, how to find this angle? Okay, there's a triangle here. Okay, after you found the x, okay, by 180 minus 103 here, right? There's a triangle here. This triangle 180 minus 28 minus x to get this angle. Then this is opposite angle. Then you can find y by using 180 minus this angle over here. Okay, that is part E. And part F, I will teach you how to do, okay? Because part F is a little bit harder, but you can try first before you continue watching this video. Okay, so this one, what I'm gonna do is I'm gonna draw a line. Okay, so we have two theorems here. One of the theorem is twice, okay, the twice thing. Okay, angle at the center, this is angle at the center, this is angle at the center, 58, is twice the angle at the circumference. So the circumference here is this. Okay, this is not butterfly, butterfly must be on the circumference, but this is not butterfly, this is twice. Okay, angle in the center, which is 58, is twice the angle at the circumference. So this angle at the circumference here will be 58 divided by 2. Okay, so 58 divided by 2 is 29. So this angle here is 29 degree. And this whole thing is 100, right? According to the question. So this angle here will be 100 minus 29. And I get 71 degree. Okay, and then this cyclic quadrilateral here, you look at these 4 points on the circumference. This is called cyclic quadrilateral. So meaning to say that the opposite angles, okay, this plus this x is 180. Not the 100, 100 is everything, right? But I already found 71 here. So this part here is 71. This is 29, that's why it's add up to 100. So my x will be 180 minus 71. So I get 109. Alright, so I teach you how to do this question already. Okay, so do it by your own. And next question is question 9. Okay, question 9, I give you a hint also how to do this question. Okay, so we're finding ADC. ADC is this. Okay, before you find that angle, okay, I'm going to teach you this one. You need to add another line. This is the line. And you can see this is angle in a semicircle, which is 90 degrees. So this is 90 degree. Okay, so if that is 90 degree, then you can find this angle over here lah. Huh? So this angle over here will be 180 minus 90 minus 28 because of this triangle ACB. Okay, after I minus, what do I get? Okay, it's 62 degree. So 62 degree, then this is a cyclic quadrilateral, right? Because 4 of the points vertices are on the circumference. So these are opposite angles. This and this are opposite. So we can find this ADC already. Okay, ADC. Okay, do it yourself. ADC, 180 minus 62 to get ADC. Right? Okay, and ACD leh? ACD is this angle here. Okay, so this is an isosceles triangle. So 180 minus ADC, the one that you found later, divide by 2. Okay, divide by 2 angles because of this isosceles. Then you can find ACD. Okay, this one you do it yourself. Right, okay, let's go to try it 10. Try it 10 is not hard. Try it 10 here, I'm going to zoom in to find the x. Okay, this is not a cyclic quadrilateral. I give you the hint already. So if you draw a line here, you will have 2 cyclic quadrilaterals. Okay, so as I teach you just now, this one's 77, so here is also 77. Alright, and if this is 75, then this is also 75. Right? Okay, so you can find your x lah. Okay, opposite angle for the x and opposite angle for the y. When I say opposite angle, they are not the same. You must use 180 to minus it. Okay, so you can find your x and y. So x is 180 minus 75 and your y is 180 minus 77. Right? Okay, so that's all for question number 10. This one also DIY yourself. I give you the hint already. So for today's lesson, lesson 23 will be try 12 and your notes are and exercise 3.2, question number 4, 9 and 10. Okay, that's all from me today. See you guys again next lesson. Bye!